Hello everyone and welcome back to my channel. So in this course we are going through the skills required for Generative AI Leader Certification exam. In the previous videos we have seen first chapter, which is Beyond the Chatbot, and now we are on the second chapter, which is Gen AI Unlock Foundational Concepts. In my previous video, part 1, we have seen the introduction to Gen AI foundation concept, then understanding AI, ML and generative AI, and what is data. In this topic, we are going to see what are the different type of learnings in a machine learning. The quality, accessibility and the form of data are fundamental, but how the data is used in a machine learning depends on a specific learning method. Machine learning has three primary learnings. One is supervised learning, another one is unsupervised learning, and third one is a reinforcement learning. We will go through each of the learning one by one. When we say supervised learning, supervised models rely on the labeled data. Unsupervised model rely on the unlabeled data. And reinforcement learning learns through the interactions and feedback. Let's see what are labeled versus unlabeled data. So what are the labeled versus unlabeled data? The labeled data which has tags such as name, type or number. These tags are sometimes applied manually or by automated systems. Say for example, an image data set of a training cat detection model. We will be having all the images of cat having a label called cat, and all the images of the dog will be having a label called dog. This is how we are segregating the cats and the dog depending upon the label, whatever we are giving. Similarly, a set of customers review might be labeled as a positive reviews, negative reviews or a neutral reviews. These labels enables algorithms to learn from the relationships and make the accurate predictions. Then what is unlabeled data? Unlabeled data is a data which is not tagged or labeled the way we have tagged the cat or the dog, but it's raw and unprocessed information without a inherent meaning. Means what? Say for example, unlabeled data can include a collection of unrecognized photo, a stream of audio recordings or website traffic log without any categorization. So in this case, algorithms must independently discover the pattern and structure and there are no pre-existing labels to guide the learning processes. So this is coming under the unlabeled data. Now let's see what is supervised versus unsupervised learning. Supervised machine learning trains model on the labeled data, whereas each input is paired with a correct output. So it allows model to learn the relationship between them. Then what is a model goal? So the model's goal here is to identify the patterns and the relationship within the labeled data. It learns from this data and the pattern and gives accurate predictions. Example of the supervised machine learning is predicting the house prices given the previous year's trend. A model is trained on a data set where each house has labeled the data such as size, number of bedrooms, location and the corresponding sale price. This labeled data allows algorithm to learn the relationship between features of a house. Once the model is trained, they can predict the price of new houses in this feature. This is how the prediction algorithm works. Prediction algorithm uses supervised machine learning. Then what is unsupervised machine learning? Unsupervised machine learning models deal with raw, unlabeled data to find the natural groupings. Instead of learning from the labeled data, it finds out the pattern from the unlabeled data. For example, unsupervised learning algorithm could analyze customers' purchase history from your company's database. It might uncover hidden segments of customer with similar buying habits, even though you never explicitly labeled those segments. But this can incredibly valuable for targeted marketing or product recommendations. So in short, unsupervised learnings help you to understand underlying structure of your data and uncover the insights of that data that you are also not aware about. And then what is reinforcement learning? Reinforcement learning is all about learning through the interactions and feedback. So imagine a robot learning to navigate a maze. It starts with a knowledge of a maze layout, but it will explore its interactions with maze and collects the data, and next time it will not bump into that particular area. So what robot is doing? Robot is taking the feedback from its surrounding and working on the data. It will not bump in the same direction again and again. It's similar like a training your pet. You reward your pet for a good behavior and discourage for the bad behavior. And over the time, pet learns to perform the desired actions. So similarly, in reinforcement learning, algorithms learn to maximize the rewards and minimize the penalties by interacting with its environments. This type of learning is particularly useful in a situations where you can't provide explicit instruction or a label data. For example, you could use reinforcement learning to train self-driving car to navigate complex traffic situation, or to optimize the performance of a robot in a manufacturing plant. So what are the examples of machine learning approaches on Google? So predictive maintenance with a Vertex AI. So it's a supervised learning. And how does it work? So it works by training a model on a sensor data from a machines like temperatures, pressures, and a vibration. Vertex AI can predict when a machine is likely to fail, enables proactive maintenance and reducing downtime. Supervised anomaly detection with a BigQuery ML. It's a unsupervised learning. So how does it work? BigQuery ML can analyze historical transaction data like amount, location, time to identify pattern and flag unusual transaction that deviate significantly from the normal. So, and the third one is a product recommendation with a Vertex AI. It is coming under the reinforcement learning. And how does it works? Vertex AI can train a reinforcement learning model to recommend products to their users based on their browsing history, purchase behavior, and other factors. The model learns to maximize the user engagement and sales by continuously refining its recommendations. So all the recommendation engines work with a reinforcement learning. Now it's a quiz about the types of machine learning. Let's see one by one. A developer is adding an AI component to a complex video game. The AI interacts with the game environments, taking actions and receiving rewards or penalties based on the outcome of those actions. Through trial and error, the AI learns which actions lead to highest cumulative rewards, effectively learning to play the game. Which learning is this? In short, it is taking a feedback and working on the feedback and giving some another action. This kind of learning is a reinforcement learning. Let's see. Yeah. This is a classic example of a reinforcement learning. The AI agent learns through the interactions with an environment, receiving feedback in the form of rewards or penalties. The goal is to maximize the cumulative reward over time, which is the core principle of reinforcement learning. Now let's see the second one. An email An email provider uses supervised learning to classify incoming emails as their spam or not spam. The model is trained on a dataset of email that have been manually labeled as a spam or not spam. So we have discussed wherever it's a labeled datasets, it's always a supervised learning. So what are the labels here? Spam or not spam is a labeled in this example. Let's see. Yes, that's correct. Supervised learning. This is a clear instance of supervised learning. Yeah. Yes, it's supervised. This is a clear instance of supervised learning. The model is trained on labeled data sets, email labeled as a spam or a not spam. And the goal is to learn mapping between the input, which is email content, and the output, spam or not spam classification. The presence of labeled data is defining characteristics of supervised learning. Let's see the third example. Discovering the underlying topics in a collection of documents. For example, analyzing a set of news articles to identify the main topics being discussed. So there is no structured and there is no labels present. We have already discussed that when there is an unlabeled data, it's an unsupervised learning. Yes, this is an example of unsupervised learning. The task is to find the patterns or a structure in unlabeled data, which is news articles. Topic modeling, which aims to discover underlying topics, is a common application of unsupervised learning. Since there are no predefined labels indicating the topics, the model must discover them on its own. So, what are the key takeaways here? Machine learning models can be trained using supervised, unsupervised, or reinforcement learning approaches. The choice of approach depends on the specific task and the nature of the data available. Now let's see the next chapter. Turning data into learning using Google Cloud. Here, Google Cloud offers a comprehensive suite for data tools and management capabilities tailored for ML workloads. These tools and capabilities are designed to support the entire ML lifecycle, from data preparation and model training to deployment and the monitoring. So let's break down the key stages of making a data accessible for AI. Here, the first step is gathering the data, or as a data ingestion. We collect the raw data from the various sources effectively, train them and test our models and see are we getting the correct outcome or not. So Google Cloud supports data ingestion through several tools. First one is a PubSub, which handles real-time streaming data processing regardless of the structure of the data. Another one is a cloud storage, which is well suited for storing unstructured data. Cloud SQL and the Cloud Spanner are used to manage unstructured data. So these are the tools which we can use for data ingestion. The second step is prepare our data. Data preparation is a process of cleaning and transforming raw data into usable format for analysis or model training. This involves formatting and labeling data properly. So Google Cloud offers a tool like BigQuery for data analysis and Data Catalog for data governance. These tools help prepare data for ML models. With the BigQuery, we can filter the data, correct its inconsistencies and handle missing values. And with data catalog, we can find out relevant data for our ML projects. This tool provides a centralized repository to easily discover datasets in our organization. Now we have gathered the data and prepared the data. The next step is training the model. So in this process of creating ML model using a data is called a data training. Google Cloud's Vertex AI platform provides a managed environment for training ML models. So with Vertex AI, we can set up parameters and build models using pre-built containers for a popular machine learning frameworks, custom training jobs, and the tools for a model evaluation. Vertex AI also provides access to powerful computing resources to make a model training process faster. And now we have trained our model. Now the next step is deploying and getting the prediction out of this model. Model deployment is a process of making a trained model available for use. Vertex AI simplifies this by providing tools to put the model into action for gathering the prediction. This includes scaling the deployment, which means adjusting the resources allocated for the model to handle varying amount of uses. Once it's deployed, we need to manage our model too, because the data is changing frequently. Then we have to make the changes in our model according to our data sets frequently. So let's see what's in manage your model. So model management is a process of managing and maintaining models over time. Google Cloud offers tool for managing the entire life cycle of ML model. This includes versioning, performance tracking, drift monitoring, data management, storage, and automate. The first one is versioning. Versioning keeps a track of different versions of the model. Performance tracking. So it reviews the model metrics to check the model's performance. Drift monitoring. It watches for the changes in the model's accuracy over the time. Data management. You can use Vertex AI Feature Store to manage the data features in the model uses. For storage, you can again use Vertex AI Model Garden to store and organize the model in one place. To automate, we can create a pipeline using Vertex AI to automate our machine learning task. You can also connect with you can also connect them with your existing tools or build your own custom solution. And throughout the entire process, Google Cloud's infrastructure ensures you to provide a solution which is available and reliable. At the same time, identity and access management keeps your data safe and ensures only the right people have the right access. So what are the key takeaways in this? So here we discuss about the ML cycle. So it starts from the data ingestion and preparation, then the model training, model deployment, and the model management. And we are the Google Cloud's tool available to do all these tasks. So this is what is mentioned in this topic. Let's see the quizzes. So what is a primary way that agents learn in a reinforcement learning? Option 1 is by analyzing large data set of labeled example, by explicitly programmed with correct actions, by interacting with environment and receiving feedback, by observing and imitating expert demonstrations. So as we already discussed in this video, reinforcement learning is all about receiving the feedback and learning from the feedback. So option C is a correct answer. What is the primary purpose of data ingestion and data preparation stage in ML workflow? Option 1 is monitoring model performance, deploying trained models, collecting, cleaning, and transforming raw data, training machine learning models. So in data ingestion, we talk about gathering the data and cleaning it, collecting it, and the transforming raw data into the usable data. So here Option C should be the correct answer. Arrange the ML lifecycle steps in the right order. Model training, data ingestion preparation, model deployment, model management. So we have seen that the first step in the ML lifecycle is data ingestion and the data preparation. So let's skip first to two options because it starts from the model training. Let's see from C and D. Data ingestion and the preparation, model training, model management and model deployment. And the D is data ingestion and preparation, model training, model deployment and the model management. Here, once we ingest the data and then we do the model training, we have to deploy the model, and then once we deploy the model, we manage that model. This should be the correct answer. Always remember, once model is trained, you have to deploy this and management comes at the end. Consider you are working on one of the functionality where data is changing frequently. So what involves in the model in management is changing the data sets as per your requirements. Always remember, after model deployment, model management is a necessary step. What is a model in context of machine learning? A set of predefined rules for a decision making, a type of computer hardware, a visual representation of data, a complex mathematical structure that processes inputs to generate output. In last video, we discussed about the model in detail. It's just like a complex mathematical structure and the process inputs and generates output, similar like a complex formulas. Let's select the D option. Which of the following is an example of unstructured data? A collection of customer reviews in the form of free text paragraph, a spreadsheet with customer names, address and a purchase history, a data set of product IDs, prices and inventory levels, a table of employees' names, salaries and job titles. Here in all the three options, there are labeled. There are a label like a customer name, address, purchase history, and there is a relationship between one entity to another entity. But in the option first, it's a customer reviews in the form of free text paragraph. So it's a unstructured data. How does consistency impact AI model training? Inconsistent format and the labeling can confuse the model and hinder learning. It increases the speed of data retrieval. It reduces the need of data storage. It ensures data is relevant to task. So this should be the correct answer. Yeah. All the answers are correct. By this, we have completed the first topic of second module, which is a core Gen AI concept. In next video, we will see the foundation models. In that, we will see deep learning, generative AI, foundation models, and how to choose the models. Then Google strategies for foundation models and its limitations, followed by quizzes. Stay tuned and happy learning.